Well, hello everyone. Welcome to Module 6. Module 6 is going to teach you how to use functions. We'll also see how you can take functions and organize them into classes. We will see how you can use the PyCharm debugging engine to help you, debug your code. And we will finish up by talking about how you can enhance your GitHub repositories by creating a simple web page to go along with it. So, as always, there's lots to do. Let's get started. The first thing we're going to talk about is how you use functions in general. Now, we saw a little bit of this in the previous module. So, here's an example. It's a simple example. I've created a function called process something. The process something function has a print statement that says I'm, and underneath that another print statement that says processing data. Of course, when I start the script up, what will happen is that the function will load into memory. Once the function is loaded in memory, the function will then be called. You must make sure that you define the function first in a Python script before it is called. Otherwise, it doesn't work. In other languages, that's not a requirement, but in Python, it is. And in this case, the only thing it does is present out I'm processing data. It is often the case that we use functions to, process data. We can also use it for presenting data. In this particular case, the function is doing less processing and more presentation. So perhaps I should say that this function should have been called presenting something. That might have been a better name. But it does highlight how easy it is to create a function. Now, in this function, there's not a whole lot of things going on. And usually the functions that you start off with will be like that. But as time goes on, you'll want to do more with them. One of the first things you'll want to do is be able to pass in some values for processing. To pass in values for processing, you use parameters. A parameter is defined as a variable being used by the function as a parameter. The word parameter is a description of the job the variable is performing. So, my process something code is using the parameter message, parameter. And I'm printing out the contents of parameter message inside of the function. Now what's going to be passed into the message parameter is this argument, arg space ABC. I just made up some data that I put together that I'm going to pass into the message parameter. The term parameter and argument are often interchanged by people, but it's not the right way to talk about them. Arguments get passed into the parameter, and the parameter receives the arguments. So, although I won't always use a little prefix to designate that, I will try to always use the correct terms. And I would recommend that you try to as well, although you will find in the industry so many people are using the incorrect terms that you just kind of have to go with the flow. In other words, don't worry about it too much. In this case, you can see that the results are the parameter that was passed the argument, and the argument gets displayed. And that's exactly what you would expect. And you can continue to add on more parameters as you wish. There's no practical limit to how many parameters you can put in. Of course, 2 parameters would certainly be easy to do, and it would look something like this. Value 1 and value 2 are my parameters. 10 and 5 are the arguments I'm passing into the parameters. The 10 is implicitly put into the value 1 parameter when I call the function. So when I call the add values function, the value of 10 will implicitly be put into value 1, the value 1 parameter. By the same token, the value of 5 is implicitly put into the value 2 parameter. The reason why it's done like this is because they are in the same order. Of course, The calculation will be performed of adding value 1 and value 2, which allows me to capture an answer, which allows me to present the answer using a simple print statement. This is very similar to code that we've done previously, but now it's inside of a function. Why don't you take a few minutes to try working with functions. Now, notice that when I made my parameters, I didn't put a prefix on them. And you can start practicing that as well. The way it works in Python, the Python language specifically, is that we not only use lowercase for the parameter names, and we don't typically put in a prefix to indicate the data type, but we also use something called snake casing. Snake casing is a slang term for when you have a variable name that uses underscores, all lowercase with underscores in between the different components that make up the name. It is not my preferred style, but I have to say that using lowercase names for the parameters is a very common thing to do in the industry. And as such, I will start doing that in this module as well. You'll see that currently I'm using a prefix on my variable, and I'll talk a little bit more about when and when that might not be appropriate as well later on. But for right now, let's go ahead and try practicing working with some functions in Lab 6. So Lab 6 is very similar to what we just looked at, but I want not only the sum, but the difference, the product, and the quotient of two numbers. We're going to create a function, so a single function that prints out all of this information to simply perform the calculation of addition, subtraction, multiplication, and division. And when you get done, you should see a result something like this. Go ahead and pause the video and see if you can make that happen. I'll see you back in a few minutes. Okay, let's take a look at an answer for Lab 6.1. Your code may look something like this, where you define the title, a description, and your changelog, and then define the function at the top. I've called it, instead of add sum or add values, calculate values, since we're going to do more than just adding. I provided two parameters, and I use those parameters to perform various different operations. You can see here that my operations all have a slash. That is a bug. Normally, I would change this over to a plus sign, a subtraction sign, multiplication sign, and division, and that would be the proper answer. But for now, let's go ahead and continue working with it as it is. You notice that I'm printing out the results, converting what I expect to be a floating point value, thus the prefix, into a string so that it can be printed out. As you may know, a lot of these numbers will implicitly be converted to string for you, but I have found in programming it's often a good idea to be explicit about your desire. Let's go ahead and run it and see what happens. At first, it may feel like everything's running fine, but on closer inspection you can see that the values are not correct. Of course, we know why that's true. It's because the logic is incorrect, even though the syntax is correct. This is a logic error. This is a logic error. And so we need to look it over, change the logic, and test it again. Much better. The act of debugging is often deciding whether or not something is a runtime error, in which case it only happens when it's running or during the time it's running, or a logic error, a design time error, something called a design time error, in which case you get an error when you are typing in your code, such as forgetting the parenthesis. So design time error, forgetting the parenthesis, runtime error. It only occurs when you're running, such as a file isn't found, or logic error, in which case everything runs just fine, but you're not getting the results you expect. One common practice you will see in programming is using variables for arguments. What this looks like is you've got some variables here, value 1 and value 2, or should I say floating point v1, floating point v2. Now currently I don't have any values in there as of yet, but I'm planning on putting some in there later. So I will just note them at the top and then later on use them. Now, when the program starts up, it'll load the variables, but they won't have any value in there as indicated by the keyword none. It'll load up the function, add values. And then I'll get down to the code, the presentation code, where it asks for input from the user. If the user enters in a 5, as shown here, then the value will be picked up as a string, converted into a floating point value, and placed in the variable. The floating point v1 variable will no longer be empty. It'll no longer be at none. It'll now have the value of 5. And the same thing is going to be true when I pick up value 2 and enter in 10. When that occurs, I can next go ahead and call or print out the contents of the variable, such as this. The sum of the first placeholder is floating point value 1, and the second placeholder, floating point value 2. These symbols right here allow me to define that I want a floating point value instead of just a string value. That displays the contents of the sum of 5 and 10. Notice that because I have a 2, I'm only seeing 2 zeros after the decimal point. Now I can see, if I go back over and look at the code, that changing this over to 3 or removing it altogether has an impact. Notice that removing the number, it may still be considered a floating point value, but I'm not seeing anything after a decimal point. By putting in the 3, I'm seeing 3 digits after the decimal point. This is just a nice way to print out the contents. But notice that when I use this feature, it's expecting some kind of indication about what I want to display. Using an S for string, I don't have as much control as using the original. This notation with a F for floating point and some kind of number is also pretty common in the industry. So, although it's not my favorite perhaps, I want to take a minute to show you it. Okay, that takes care of that line, but let's go on to the next line. Well, for this one, I'm using the is keyword, and then instead of the normal ending of the print statement, in which case it would put a carriage return, so there's a carriage hid one right here. Instead of that, I'm just putting a space, or I should say, there's no space in there. I've decided to put the space here instead of here. Either one would work. Now, I call the function add values to get the value of, I should say, the sum of the two numbers. And you can see the answer is, in this case, 34 plus 5 is 39. There'd be lots of different ways to write this code, but the key thing we're looking for here is the fact that I declared variables first and used them later on as arguments. This is handy if you think that your variables will be useful to you in more than one spot. Otherwise, I could just go ahead and submit the numbers myself like this, or even just collect the input like this. That would work as well. That's one of the things about programming I really kind of like. The fact that it can be so creatively different every time somebody writes the code. Uh-oh. Can't concatenate that. It must be that it's trying to print out the values and not succeeding because it's being picked up as a string. Apparently my copy and pasting skills aren't nearly as good as I was hoping. There we go. Let's try again. Notice that I've got a nice little error message. May not be the most friendly one, but it did tell me what was going on. Okay, let's try again. Right click, run. Let's try 5 and 10 again. And we can see that we get the same response, although it's not as nice or as pretty. You will often want to return data from a function. To do so, you use the return keyword and then follow it up with some data that you wish to return. When the function finishes running, it'll return the data and you can capture that data in a variable. If you plan on using that variable in some other part of your code, you can use that capture the data like this. But if you plan on just displaying it once, you can just go ahead and use it directly like this as an expression. So your choices when you use a function that returns data is to capture the value or just use it immediately by evaluating the function as an expression. Here's an example of both options. You can see that my add value function, much the same as it was. It returns the floating point answer that I'm expecting to get when I add the two values together. Now, I'm going to pass over some integer values, so it's not really going to be a floating point. I should have thought about that. That's all right. We'll leave it as it is right now. I expect the floating point value to be useful to me at some other point, so I capture it in a variable and then use it later on. If I anticipated not needing it any other place in my code, I could just go ahead and use it directly as an expression right in the same line as the print statement. Both options work, and you'll know when to use it. It'll become very much second nature as time goes on. Now, one of the important advantages of using a return code, or return value, is that I have separated the presentation code and the processing code a bit further. Previously, I had a print statement in my function, but that's no longer true. Now, I don't have to do any presentation of input or output to the user, or from the user, in my processing code whatsoever. That's an improvement. It makes my code more reusable and portable. Instead, by returning the value, I can now place the presentation code down below and separate from the actual processing code, dividing the separation the layers of concern into our 3 tiers of data, processing, and presentation a little bit more easily. This is a good practice to follow. As you'll see when we get towards the end of the course, it just makes working with more advanced code substantially easier. There are times where you wish to return more than one value from a function. And while not all languages allow you to do this, Python certainly does. In fact, they make it pretty easy because you can use a tuple, which can be packed and unpacked quite simply. Here's an example. First, I declare my variables. That's the data section of my code. Then I create a function, define a function. That's the processing layer of my code. And then I put together the presentation layer, which allows me to get input and print output to the user. At first, I go through and collect the first value from the user, convert it to a floating point value just to make sure that that's what I want, and put that floating point value that the user enters in to floating point value 1. Next, I do the same thing for 2, and then I call the function. Now, as I'd mentioned, the function has to be defined before it is used in Python. So when this function gets called, the variables are used as parameters. Those variable values we passed over. And in my example here, I'm using 5 and 10 again. So 5 gets passed over to value 1, 10 gets passed over to value 2. I do my addition, and I capture the answer. But this time, instead of just returning the answer, I've chosen, just to show it can be done, to return 3 values. You may remember that if we don't use parentheses to create a tuple, doing something like this, where we put a comma separated list of values, will automatically create an invisible tuple for us by packing it. And when the function finishes up, we can unpack the individual items, value 1, value 2, and the result, the answer, by just capturing it down here. It's kind of interesting how this actually works. By doing the unpacking, it means that I can quite simply call a function and get back multiple values. Of course, then I can use those values in any way I want, but this feature is, well, rather popular. Now, of course, this only applies to Python tuples. Other languages, you won't find this feature. In those other languages, though, we still find things like a list object being used to do the same thing. So this next example is almost the same, except that now I am indeed using a list, which is a little bit nicer in some ways because it's explicit as far as what you're looking at, but a little bit more cumbersome in other ways because now I have to extract out the individual items or elements of the list myself using these indexed subscripts. Certainly not the end of the world, and it does the exact same thing. But, as you might imagine, many people prefer the way the other one reads. Let's see if you can give it a try. What we want to do is, in the next lab, we want to see if we can return a tuple that has the sum, the difference, the product, and the quotient in it. It's almost the same as last time, so you can probably start off with the previous version, modify the code, and then send back the results. Make sure that you get an answer that is similar to the one shown in Figure 8. And write down how your code works just to cement it in your mind. When you're done, go ahead and unpause the video and we'll go over the answer together. See you in a minute. A few minutes. Let's take a look at an answer. So first of all, I go ahead and create my header at the top and define my various different variables that I'm going to use. So I'm going to have a first and second argument. I'm going to have some variables for picking up the results, the first result, the second result, and the third result, and actually even a fourth result in this case, although I see that I have a copy and paste error. There we go, much better. Okay, next, I create my function. It starts off the same way. I have the sum, the difference, the product, and I'm missing the quotient. Notice that I've commented it out because I want to kind of show you something in this example. Also notice that I'm no longer using the prefix for these variables. That's kind of common in a number of languages. Certainly it would be common in Python not to do this. So I'm going to go ahead and change over. Not necessarily because it's wrong to do it either way. It's just that I think you'll find it useful to kind of get to see it in different varieties. Also, I kind of agree on this particular case that when I'm using variables within the function, I often don't need to make them as fancy as the ones that are outside the function in the body. I'll explain a little bit more about that in just a bit. But one of the reasons why is because there's only usually a few lines, or certainly fewer lines, in an individual function than there are in an entire script, where I may have many hundreds of lines. Be that as it may, I've chosen to call it sum, difference, product, and I've chosen not to use quotient. The reason for that is I want to show that you could pack up a tuple with the values even if you just use the expression to capture the value. There's really not any reason to use a named variable if you're never going to use it again. That's what I'm doing here. In the end, it would still work, and I would capture it down here. Other than that, it's just a matter of doing a copy and paste and making sure that I'm careful to change the names as I do a copy and paste, which is sometimes easier said than done. Now I test it, enter in some values. I'll start off with the values in the picture just to be sure that it looks the same, do a comparison, and also do a logic check to make sure that it looks right. The sum of 5 and 10 is not 0.5. There's something wrong with that. Oh, there it is. You probably saw it earlier, but if not, that was definitely something that you had to watch for. It's really easy to get these little logic errors, and sometimes the logic errors can be the ones that are more difficult to find. Oh yes, much better. Remember that my answer to the lab and your answer do not have to look exactly alike. But if you're getting the same response, you did a great job. Let's move on. Using arguments for your parameters is really common, and as such, a lot of people over the years have added additional options you can use when working with your arguments. Let's take a look at some examples of these, starting with using a positional versus a named argument. So, when I define my function, I have my two parameters. But when I call the function, I can identify the name of the parameter when I pass over the argument. Doing so would allow me to, well, do things like this and still get the same result. The order of the parameters and arguments are no longer important. The names are. When I leave off the name of the parameter and just submit the arguments, in this particular case, I would probably get different well, actually in this particular case I'm doing addition, so I wouldn't get a different result. but I certainly might get a different result if I was doing subtraction or division. And it might be hard to spot because my arguments are only off by just a little number here, and I might not be able to see that. By using named arguments, so naming the parameter and then putting in the argument instead of just using positional arguments, you can help make your code easier to read and less prone to error. Another feature that people have added over the years is the ability to use a default value. When using a default value, in the parameter you just define a default value. It can be anything you want it to be. Common ones are a starting value of like 0 for numeric values, an empty set of values, such as an empty tuple, maybe a list, an empty list, or the keyword none. Then, if you only pass in one of the arguments into one of the parameters, in this case, I'm passing in the value of 10 into, let me zoom in a little bit more, the value of 10 into the floating point value 2. That gets placed in here, so 0 is no longer used. Instead, 10 is being used. But because I didn't identify any value for value 1, 0 is used. And as such, we would see that the sum of 0 and 10 is indeed 10. Now, it's important to note that if the user was asked to enter in a first value and a second value, and yet you never used that first value and only used the second value, it would cause confusion for the user of your code. So while this is an example of what could be done, it's certainly not an example of what should be done. You do not want the user to be surprised whenever they run your code. Many modern languages allow you to create multiple versions of a function. Now, these multiple versions are referred to as overloads, and they will typically have a different number of parameters, or perhaps parameters with a different set of data types. Now, since Python doesn't really restrict what you put in your variables, there's no strongly typed variables, and it automatically determines what type of data your variable or parameter is going to be when you use it, we don't have that same kind of functionality in Python, but I do want to talk about it and show you an example. So imagine some code that looks like this, like the pseudocode. In which case I have a function, it has no parameters, I return some data. That'd be one version of my function. Another version would be the same name, but it would have a single parameter, and I've designated that that parameter would be an integer. Another version of the function, same parameter, number of parameters, but a different data type for the parameter. And yet a fourth version of the function, in which case I have 2 parameters. I could continue adding on multiple versions of the function, each one being a new overload, until I had all the combinations that I wanted. Now, in languages that don't have this feature, if they have a default option for their parameters, you can do something similar. And that's why we do it in Python. So in Python, what we do is we define default values. And then we check to see whether or not they've used the default, or as in this case, my simple version here, we just go ahead and use whatever they've asked for. So when this code starts to run, it'll call calculated values. Since I didn't pass in any arguments, it's going to use 0, 0, and the plus operator. It'll come down, ask the question, was the operation the plus operator? And if it was, it'll go ahead and add the two values together. On the second time through, things change. With this one, This one I'm passing in, excuse me again, apparently I can't aim very quick. And this one I'm passing in the 5 into value 1 and 10 into value 2, but I'm not doing anything with the operation, and as such, when it starts going through the if statement, it's going to use that one. This is going to evaluate the true, and it's going to do addition. But on my third version, that one's different. That's because I passed in an operator. It will replace the plus operator that was the default. And of course, it'll perform the multiplication because of the logic in my function. Now, this can be kind of a nice little feature if you would like your functions to be able to perform different sets of statements, but have everything contained in a single function, instead of having to create multiple functions, each with a different name. You see, in languages that don't have a default parameter option, or excuse me, default value for their parameters, and you want to do something similar, you just have to give each function a unique name. But that can be quite cumbersome, since if you have many different versions of the function, you end up with lots of functions that are very similar in name, but not exactly the same. In any case, you can certainly have multiple functions within your script, and you get to choose when you're creating it which way you want to create these multiple versions of a function, either using overloads in the form of a default parameter like we do in Python, or as in other languages like C# or some other languages out there like Java. You can use overloads where you do a different combination of parameters and data types. In the end, if you're not writing the code, you just have to use what other people have. And to tell you the truth, you've been doing that all along. Take a look at the print statement. You can see that there are 5 parameters that are part of the print statement. And if I don't specify anything, it uses one of the versions. If, on the other hand, I do start specifying things, like one of the options is to indicate the separator. The separator is supposed to be a string. I can define a different separator. We've done that. Or the end, which is also supposed to be a string. There's also a couple other ones in here as well, but we're not going to look at those right now. So depending on whether or not I pass parameters into the function, the print function, I will get different results. And it's done by using code similar to what we just looked at. They're deciding whether or not the default was used, and then responding based on that decision. One common variation on this is using the none keyword as a default value. So, or should I say default argument, same thing. So what I do is I use the word none instead of like a 0. Now if I do that, I just check to make sure that they are either using some value, argument value they passed in, or they're using the default value, using a simple statement like this. Is it true that value 1 is none, or value 2 is none, or operation is none? If any of those are true, because I'm using the OR statement, then I'm going to print in the answer, error, missing arguments. So commonly you do this so that you can do some simple error handling where you are going to tell people that you want to use an actual value here, and you check to see whether or not they passed one in or just use the default. Now certainly that's not the only thing you can ever do with it, but that is a common thing to do. What is not common is to actually place error messages in a variable like this. And we'll see a better way of doing it in the next module. But for right now, the code's easy to read, and we'll just move on with it. Now, if everything goes well, and they put in the two numbers, and they put in some kind of operator, then it'll go ahead and perform the action. Now, if they don't put in a plus, a minus, a multiplication star, or a forward slash division operator, it will result in an error. And then when the function runs, I will get an error message. Let's see if we can see this in action. So here's that same code. And I'll go ahead and run this. Notice that the first call is without anything, and as such it gives me none, 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 and error missing arguments. That's because I'm making a tuple and using that. You can also tell because the tuple is being created because of the parentheses there. Next, I pass in 5 and 10. Well, I'm still missing an argument. So 5, none, 10 is resulting in an error, a missing arguments error. But when I pass in something correctly, I will indeed get the actual answer. 5 times 10 is 50. Now do be aware that if I pass in an operator that didn't make any sense to it, they would not find any match, and as such, it would still result in an error. It's just a different error than the ones that we had previously. Once again, we're going to talk about error handling a little bit more in the next module. Well, quite a bit more in the next module. So I'm going to save some of that for later. Another variation of using a function has to do with using parameters as a reference type instead of a value type. Now, it's been a while since we talked about this, so let's take a quick review about value types and reference types. In other languages, it can be a little clearer as far as how these two work, and you can be a little bit more specific about which one you want to do. In Python, as so many other things, it's automated. As we talked about before, simple data types will act as value types, and more complex data types will act as reference types, at least some of the time. So you need to kind of test things. And the example we used back in Module 2 looks something like this. I've got two variables, x and y. I set the value of x to 1, and then I take y and set either the reference or the value of x to y. Now, since x is actually a simple integer data type, it's going to set the value. If I change the value of x to 3 later on, it does not affect y, and as such it prints out 1. That's because when I passed over the value of x into y, any changes to X later has no impact on Y. But that's different when we use complex data. If I use a list by indicating a square bracket, and then I pass over a reference to that list from the X variable to the Y variable, any changes to the X variable will have an impact on Y because the two are pointing to the same location. And as such, when I ask it to print out the value, instead of seeing 1 and 2, we see 3 and 2. Because X and Y are linked to the same space in memory, and that was done when I passed over a reference to Y right here. Now, once again, if some simple data you may have to test, let's take a look at a string. Strings can be considered complex, so you always want to test things. I'm going to see what happens when I pass over X to Y. I'm looking to see whether or not the impact will be they will be linked to the same location, or they will just have the same value for that line in blue that I'm highlighting right now. If I later on change X to Robert, I'll see that printing out Y had no impact on, changing X had no impact on Y. When I print out Y, I still see Bob. That's because the value was passed. But once again, if I use something like a list, that's going to change. It will indeed have an impact. You always need to test. You always need to test. So if I come over here and let's say I want to use parentheses instead. Now we'll try this. Remember that this is a tuple, but tuples do not allow you to make a change. So we don't know whether or not that would work unless we were to pass over another tuple. This will reset the variable of X. And you can still see that Y has not changed. When we reset X, it didn't affect Y. So it's acting as a value type. In other words, I passed over the values from X to Y, so that when we print out Y later on, we have those values. When in doubt, you have to test it out. That's always the thing to take away from this. As I said, in other modern languages, you can choose to pass arguments into the function by value or by reference, typically with some kind of indicator. So like in the C# language, it would look something like this. Now this is pseudocode, so it's not really any language at all. But you can see that I've defined that I want to pass over an argument into the parameter by value or by reference. C# uses value and reference. SQL, the SQL programming language, Microsoft SQL Server, implicitly uses value unless you use something like the output keyword, which is similar to ref. Actually, C# has output as well, but there's a subtle difference between ref and output. The point is that in other languages, you can be explicit about what you want. But of course, Python's different in the fact that it automates so many things. So, that being the case, if you pass over a complex type into the function, you'll need to double check everything and debug your code very carefully to make sure that the result you're getting is what you want. Here's an example from listing 13. Now, I've set up a list in a dictionary. I'm not using a tuple in this case. I'm using a list in a dictionary. And because I'm going to call it a little bit more complex, I'm going to go ahead and use snake casing just to show an example of it. Remember, that's popular in Python. So I will call the function down here, passing over my list, and then just using the index number on the subscript to access the various different elements of the list. Now, if I'd passed over a tuple, I could unpack it, work with it, pack up a new tuple, wouldn't be the same tuple, pack up a new tuple, and then send it back as a result. That would be one way of doing it. But I'm not. I'm actually making a reference, and I'm just passing the reference along. You see, all answers is going to receive not the value. The value is currently a bunch of zeros. It's not going to receive the values. It's going to receive the address to where those values are at. It's going to receive the reference. And as such, any changes, oops, I should say all answers. Okay, sorry about that. So any changes to one affects the other because they're linked. The same thing is true of a dictionary. Dictionaries have that same feature. So any changes to the one give us the other. The nice thing about the dictionary, of course, is that I can use the key instead of just an index value for the subscript. Now, doing this is not required. It's optional, but people do find it useful. This is especially true in other languages. For example, Microsoft SQL, this Microsoft SQL language used for Microsoft SQL Server, does not have the ability to return multiple values. And as such, you have to use this kind of technique to make a reference and then fill up the multiple values in that reference. So that is something that gets used in other languages, but in Python, since we can just return multiple values with a return value, you may not see it as often. Unfortunately for beginners, you are at the mercy of other people's development code, and as such you have to learn how to use both. So many of my students find this one kind of confusing. It's certainly more complicated than using a return code, but keep your eyes open for it as you go through the examples out on the internet. Occasionally you will find it, and hopefully this will help you to kind of figure out what's going on. In general, as far as getting started, not as important as some of the other things, although the concept of value type and reference type certainly come in handy. And this is one of those places that it appears. It would be difficult to troubleshoot if you didn't know what was going on. The next thing I want to talk about is something called global and local variables and what the differences are. First of all, let's talk about a local variable. A local variable is one that's declared in a container, like a function. A global variable is a variable that's contained in the entire script. Global variables are the ones we have been declaring at the top of our script, and they can be used anywhere within the script. But a local variable is different. A local variable is declared inside the function, and any code inside that same function can see it. Both statements would be inside the same scope. The example I have here in some pseudocode is a function, and I've declared a variable called v1 and assigned a value of 15. Because the print statement is in the same function as v1, I can use it. But outside of that function, for example, if I've called the function and then moved on to another statement afterwards, outside of that function, I cannot see the code v1 or the variable v1 because the variable is no longer in scope. The print statement down here at the bottom would cause an error message saying v1 is not defined because v1 is not in scope, it's not in the same scope. This print statement would be in the scope of the entire script out in the body, and this one would be only applicable to the function. Now, we can kind of modify how this works. And let me show you an example here in listing 14. Notice I've got some variables here at the top. These are global variables, and if you're planning on using them as global variables, a common thing that people do is to flag that by putting some kind of indicator, like a G. G for global. If I'm just planning on using them as regular old variables, they're going to be global too, but as we'll see, there's a difference in my intent. And one of the reasons why we name a variable something is because we want to indicate our intent of how they're used. That's why I usually like having a prefix. Notice that in my function, I'm going to use that global answer variable, and I'm going to do so by indicating explicitly that I want to use it as a global value. I can add the two values that I given in my arguments and set it to the value of the global. These aren't just two different variables that are connected. These are the same variable. Down here, I put the word answer. That is a different variable. That is a local variable. In that case, I'm going to return it, which is the proper way to do it. With global variables, I don't need to return them because setting it on line 17 effectively changes it. It's the same variable on line 12, on line 16, on line 17, and 23. It's all the same variable. So I don't need to return that one. When I run this, although I do get the same results, I'm doing so in a very different way. Now, you want to be careful with using global variables like this because they can have some unintended results. There's an aspect of using a global versus local variable called shadowing. And you want to be mindful of this and always watch for it. So whenever you assign a value to a variable with the same name, like here I've got the value of the variable, and I'm not indicating that this is a global variable. It's just got the same variable name as my local variable. But because Python's so automatic, they're going to assume that you want to use this as a global variable. And as such, not global variable, local variable. It's shadowed the global variable. As such, you won't see the change that you may think has happened. If you really want to use it as a global variable, you have to indicate it. Now it would be the same variable. Without it, it's local. This is referred to as shadowing. You're shadowing the global variable. And as such, it prints none down here when we ask what the current value is. It's best if you're going to, it's actually best to not use global variables in that manner at all. For one reason, doing this kind of violates the concept of encapsulation, where your function should be a complete contained capsule of code that you work with. And it does make things a little bit trickier if you're not prepared for it. So for example, if I go through here and use v1 and v2, I didn't pass in any values. I'm not actually setting any values here, I'm just reading them. And Python, again, because it's automated, automatically assumes on this syntax that you want to refer to those global variables. So v1 and v2 are actually referring to the global variables and using that. Answer, because I'm doing an assignment, switches over to a local variable, and then gets used as such there. So you can see 15 printed there, but when I come back and print out the global, I'll see it's still none. I think that's confusing. I think it's confusing. When you read the variable with the same name, it uses the global variable, and shadowing does not happen automatically. When you assign a value, shadowing happens automatically. Anyway, like I said, using global variables within a function is not considered a best practice. It is discouraged that you do so. While it will work, it does indeed violate a concept of encapsulation and abstraction, which I'll go into more details about in Module 8. And, like I said, it's a good idea to kind of indicate if you're going to use a variable globally by just kind of indicating that. It's a common thing to do is in Python is not to use any prefix whatsoever, and because of that, it means that it can be more difficult to troubleshoot if you're not careful. So think about that as you're writing your code, and try to be careful of making that mistake. Putting prefixes on there can indeed help, especially when you're first getting started. To avoid this mistake, it also helps other people reading your code to understand what's going on. Now, speaking of understanding what's going on, it's a good idea to leave notes for people. Notes for yourself, notes for the people that you work with. One way to do that, of course, in a script is to put a script header at the top. But when you put functions together inside your script, you can also put a little header inside of there. This is a document string, a doc string. And it's just a little note about what this function should be doing, or what its intent is. Now, with a name like add values, most people will probably figure it out. So using a good name is a great way to note it. But as you'll see, as your code gets more complex, you may need to be more descriptive. But for right now, we'll just stick with that. Now, one of the things that's kind of advantageous about using an integrated development environment like PyCharm is that a lot of times it'll display tooltips indicating what's going on with a particular function if the developer of that function put some information in the document string. So here's an example. I put in the name of the parameters and my intent about what type of data I want to go in there, or intend to go in there, and what type of data I intend to return. So now I can use the combination in PyCharm of highlighting the name of the function, pressing and holding the Control plus the Q button at the same time, and it'll pop up a tooltip and show me what that looks like. That's a nice thing to have. That is a nice thing to have. So by doing this, I will say the parameter value is float. It's the first number to add. The second one is a float, also the second add, and the returns a float, the sum of two numbers. Whatever you put in there. Now do note that PyCharm is actually pretty smart. So it's going to show you the parameters and show you the text in my parameters. And if I put in, notice that I put in a default value with decimal points, it picks that up, indicate that it's a float, and shows me so that's the type, and shows me the default values. This little symbol, the dash and the greater than symbol, indicates the return value that's of that function. So that's pretty handy. Anyway, when you're writing your code, you can make it easier on yourself and other developers by just adding in these document strings. And it's considered a best practice to do so. It doesn't take very long to do, and it's very nice to have. So I've got two functions here, and each function, Control Q, will show me information about the function. Now this works on Python's functions as well. I'm going to highlight print, Control Q, and I can see information about the print that the developer decided to put in there. So it shows me that there is a set of values that's an object. A little star means that there could be multiple values here. Then I can put in a separator. The data type is string, the end string, and then some other things such as writing output to something else, like printing it out to like a file. So this gives me information, a little description, and somebody spent some quality time making it look right. They even put a little URL here I can click on and get more information about. Kind of handy, especially if you're writing scripts for your own company, and you can set up a URL that can go to your internal documents. Or, of course, you could do that on the internet as well, if you just have some kind of page hosted someplace. So document strings are a nice plus to have. Another thing that's nice to have is grouping your functions into classes. Not strictly necessary, but it's a good way to organize your work. Just like organizing a set of statements into a function is a great way to clean up your code and make it easier to read, you can group functions, variables, and constants inside of classes. And we're going to definitely take a look at how to make classes and make use of classes, and things like, why do I use the static method keyword or declaration or directive before my method when I put my function in a class in Module 8. But for now, I just want to give you kind of a heads up look at what this might look like, and ask for you to try to do this in your homework assignment. It's pretty easy to do. First, you make up a class. I called mine Math Processor. You use a doc string for the class, a set of functions for processing simple math. You define your functions, just like normal. Then, make sure you put a static method directive in front. Again, we'll talk about why that is later, but certainly for this module, I want you to go ahead and do that. It'll make more sense later. Now, once you do that, you need to refer to the class, use a dot notation, and then the function. This is called drilling into the class. I drill into or drill through the class to get at the functions. This is a very common notation. You'll see it all through your programming career. So it's a good place to kind of learn with something so simple. If I look over here in PyCharm, another thing that's kind of nice is the fact that I can collapse sections of my code. That way, when the code gets so busy, I can kind of hide it. Oh, it's still there. It just collapsed. And using classes to organize it that way, I find quite useful. I think you will too. Let's test out how easy this is by doing a little lab. So it's going to be almost the same code as above in listing 17, but we're going to add on two more functions, multiply values and divide values. Once again, the code is going to be very similar to this, so take a look at that and then add those two new functions and test to make sure that they work. Notice that clean separation between the processing code and the presentation code. We want to try to continue doing that, so make sure that you do that as well. Now, make sure you, after you write the code and test them, that the results look something like this. I've chosen not to use the absolute value here. It's a preference. That'll be just fine for the difference. Overall, shouldn't take too much work, but why don't you give it a try, and then I'll see you back here in a few minutes. Well, this is how my example, my code turned out. Again, it'll be probably a little bit different from yours. I'm formally defining my two variables here at the top. That's my data code. And then I'm creating my class for math processor. And I have the add values, subtract values, multiply values, and divide values function. Then I call the functions inside of the math processor class after I capture the input from the two users. I call the functions using my input to get the following results. 5, 10, and I verify that the results are correct. Excellent. Now, one thing to note, I have not been testing for situations where we get an error message. Dividing by 0 would cause an error message. And we will be looking at better ways to handle it than just telling the user before they start using your code, don't do that. Or at least more elegant ways of telling them, don't do that. So right now, I get a lot of feedback that a developer might find quite useful, but an end user might find quite scary. And we'll talk about cleaning this up a little bit in the next module. But for right now, you don't have to worry about putting a bunch of error handling code inside of your functions. I just want you to learn how to use simple functions, create simple functions, and collect them into classes. And we'll get into more detail as we go forward. Let's change subjects a little bit and talk about ways you can debug your code in PyCharm. Besides just kind of looking at it and making educated guesses and changing a code, some code and testing it again, you still do that with this debugging feature, but you have better tools to do that. Now the way it works is, and many modern development environments have features that work just like this. You look around and you find a debugging option. In PyCharm, it's right there on the context menu. When you right-click on your code and choose Run, beneath that you'll find the option to debug. You will also find that option to debug up in the Run menu, and maybe some other places, like if you're showing a toolbar. The developers of PyCharm used a cute little, I think that's a bug symbol, to kind of indicate that that's different than just running it. You see, when you run your code, when you normally run your code, the results would look something like this: 15, -5 when I was running listing 17. And you can see that the word run shows up, and I also see a little green arrow. Watch. See, it shows run, it's working. Right now it's waiting for me to enter something. Put in 5, I put in 10. It runs, and I see a little green arrow. This allows me to rerun it one more time to check things out. Now, that's what happens when you run. But if you right-click and choose Debug, you get a different window. Now it says Debug and Console, and you can click back and forth between these. They don't look like tabs at first, but they are tabs. That's because they don't have a vertical line. But when you hover over it, you can see that. You can also see this horizontal line underneath it. The console window is what we're normally working with, and I'd put in the values just like before. But I can now access additional tools and additional windows on the Debugger tab, and those make all the difference. Now, in order for me to access those and use those different tools, I need to set what's known as a breakpoint. This is an indicator that tells PyCharm that you want to pause the running of the code and wait there until you tell it to move on. So to set these these breakpoints, you click on the little margin next to your lines of code. You can set many of them. Typically you set one and do some troubleshooting, then maybe set another one, do some more troubleshooting. You can remove them by clicking on the same location and it'll toggle them on and off. Now, when a breakpoint's in place, you'll get a number of different options in that debugging window that will come alive. In other words, now they'll be accessible when your code is running in debug mode. The first one, of course, is the tab, where we can switch between the console window and the debug window. Another one is the variable window. The variables window will populate with variables that are in scope. This little toolbar up here comes alive. The third little button here allows me to step over a function. That way, if I have code inside the function, I've seen it many times, I don't want to see it again, I can tell it to run the function, but don't show me all the details, just step over it. Or this one where I've noted as a button 4, that's a step into my code versus the one in between, which is step into my code and the Python environments code. Usually I don't want to see the Python stuff because it can get kind of confusing when it switches over to somebody else's code. I want to just see my own code. And if you've stepped into a function and one out because you're done looking at the code inside of the function, you can use step out, which is designated in button 5. If you just want to stop the script entirely, you can hit the little red box and stop it. Now, as you can see, there's a bunch of other buttons around, but those are the ones you start off with. And to tell you the truth, you can do a lot with just those simple buttons. Let me give you an example. So I'm going to come over here, let's see, actually it's currently not running, so I'll just lower it. I'm going to, let me go back to something a little bit simpler. Go back to 17. And I'll put a breakpoint right here. Again, you click, I'm left clicking there, and it can set multiple breakpoints, toggling them on and off. So I'll start there on line 34. I could start up above, and it would wait till that line was called. But that didn't have any action. So instead I'm going to come down here and put it down here where the action is being performed. Try it again. And this time it pauses there. So it's a little confusing when you get started. If you put it on, like, won't even let me click here. You put it in certain locations. Like here, it didn't pause because all it did was, it wasn't an active piece of code. It just loaded it. But when I put it down here where we're actually calling the function, that was an active piece of code. It paused there, and I'll be able to actually see the function as I step into my code. So I'll click on step into. You notice that it jumps up and starts using my function. It actually did skip over that, but I can actually see that inside the add function, add values function, and I can tell that I'm in the add value function because under frames here I can see that add values function is currently loaded and the entire code module, the script file, is loaded before that. I'm currently in there, and these variables are currently in scope. The value 1 and value 2 parameters. Remember, parameters is the name of a job description. They're still variables, they're just being used as parameters. So I can see what they are. I can also see that their current values are 5 and 10, and that they're currently holding an integer. So even though I intended it to hold a float, and even though I convert it over later on to a float, it is indeed holding an integer because, again, Python doesn't enforce that. Now I would step into my code some more and I'd see it go down, finish up. If I go to the console window, I can see that it printed out 15, 5 and 10, 15. I go to the console window, the debug window, and I can move on to the next line of code, stepping into my code. It won't pause on the comments, so it goes down to the next active line of code. I'm in the subtract values, and it's going to perform this action of taking 5 and subtracting 10. Step into my code, and I'm done. Now let me try this again. I'm going to put another print statement above it and put the breakpoint there. Print statement is an active line of code, so yeah, I can put a breakpoint there. I'll start the debugging process again. And this time I'm going to move into, it hasn't actually printed anything yet. It hasn't actually ran the code that's highlighted. It's just about to run the code that's highlighted. And what I'll do is I will use the step over button to execute line 34, but not see the details of line 34, or of the function. So watch this. It ran 33. It's about to run 34, but I stepped over it. It never went to line 19, paused and showed me what was in there. But it still ran it. It's just that I didn't see the details. Also, I can see that I'm no longer in the add values function. Instead, I'm back in the main portion of the module, the main thread of the module. I'm about to run the subtract values. And if I step into it, it'll take me to the return value. Stepping in again, we'll run that line and bring back to the end of the script. Now, if I put a print statement here, and here, hey, get back there. Oh, you can't put a print statement after the return. So let's see, how do I want to display this? I'll do this. Okay, let's try this again. So I'm going to go ahead and start in debugging mode. I want to step into the code, step over the code because I've already seen the add values. I haven't changed anything there. The one I want to get to is subtract values. So I'll step over that, still running the addition. I'm just not looking at the details. And now I want to step into my subtract values function. Now it hasn't ran line 30. It's just about to run line 30, so it doesn't show get here yet or got here yet, but it will as soon as I step into the next line of code. However, in this case, I want to step out of the function. Stepping out means I'm tired of looking at the code inside the function. I still want it to run, I just don't want to see the details. So if I click on that, you can see it still ran to got here, and it returned back to 37, whereas because it hadn't completely runs that line of code when I stepped into it. So there are some other options, and other development environments have even more options, but step into, step over, and step out of are the ones that you will use all the time in your programming career. And if you practice just using those three and breakpoints and just slowly walking through your code line by line, you'll be remarkably surprised how much easier it is to troubleshoot your code and also to understand the code that you're looking at, whether you wrote it or somebody else did. So my recommendation is, as we go forward, you practice this. You practice doing this. The only way to learn how to use the debugging tools is to use them. So try to practice it. Things you can do is, again, pause, look at the variables. You can hover over variables when things are running and find a little tooltip. And this will give you the same information, but you can see the specific one instead of just the whole set. And again, just play with it a little bit. So as you're going through the assignment this week, just take some time to use the debugging tools. I think you'll be pleasantly surprised. Now, one thing I want to do in this course is to tell you more about just programming in general and how things kind of work in the industry. So last module we introduced working with GitHub. And in this module, I'm going to talk about how you can enhance your GitHub repository by creating GitHub web pages that are associated with that repository. You will see other instructors actually use this for their courseware instead of using Canvas. So kind of knowing how it's done will be useful. Anyway, the way you do it is you start off with a repository. So let's say I go ahead and create a repository called our class name plus module 6. So IT Foundations 100 or whatever it's called, dash mod 6. Just make up some kind of name that makes sense. Set it as being public. Initiate the folder, the repository, or the README file. If there's nothing in it, it doesn't initiate, and or the folders don't materialize, and then create the repository. So once you've got that in place, I want to actually add another folder. And to do that, oddly enough, you hit the Create File button, Create New File button. So if you want to create a folder, you use the Create New File button to do it. Once you click on that button, you will see a little dialog window pop up. One of the recommendations that the GitHub folks use is to make a documents folder, and you put your GitHub pages in the documents folder. You can also put it in another default folder, but that one has an implicit reference. This one be explicit reference, which I usually prefer so that it doesn't seem like magic is happening. So I would start typing in docs, and that would make the folder. Then I would type in a / and then indicate the file. And the default file they want you to use is index.md. So the extension is not like HTML. You could use that, but we're using MD for their markdown language that they use called Jekyll. I'll show you an example of that later on, but that's what it's for. Now, once you've done that, you can start typing in some basic text. It can be anything at all. Like this is my index file. I just put something in there, and then click on the Commit New button. You don't have to worry about what the text says at the beginning because it's really easy to change later on. But once you click on the Commit New, it'll create the page. Now, you will need to configure your repository to be able to use the website. So the file might be there, but it's not using a GitHub website and web page yet. To do that, you need to locate the settings option, a little tab at the top of your GitHub page. Let's see here. So right here. You click on that, and you scroll down till you find the section that says GitHub Pages, and you choose the folder you want to use. Like I said, the docs folder is one of the ones recommended. You can also have this invisibly implicit one, but I don't recommend using that. If you don't want them later on, you can turn them off by disabling them. There's a cute little theme button here, which is nice. When you click on that, you can choose between different themes. You can make your own custom theme and get more if you want. But these are kind of nice to have. I'm going to show you without that at the beginning. You can go ahead and choose a custom domain. If you have a domain, you can put something together. You can enforce HTTPS. Now on a public site, you don't have as many options as you do on the paid for site. So HTTPS, which is the encrypted version of HTTP, is going to be enforced. But don't be concerned. You can see the website and the repository even when you're not logged on to GitHub. So coming in as a guest, you can still see the files. You can still see the web page that you're going to make. So it'll just be using the encryption protocol, but it's not going to stop you from being able to see your work. Now, once the settings are done and you give it a few minutes, it usually takes just a couple of minutes for it to build. You should be able to navigate to your page using the link that they give you. So this link here, it'll be generated for you automatically when you finish up. When you start making these changes, you'll see this appear. You'll kind of see a flash that will appear, and then you want to copy that link so that you can use it and check it out in different browsers so you can see what it looks like. And that's pretty much it. Once that's done, you can click on the link. You'll navigate over and you'll see the name of that page. And your little default index. Now the index, if there's a folder called docs, and there's an index file in there. The index file is a starting point. It's like the main script. It's where you're starting from. You can have other files in that folder and you can link to them. But if you don't specify any particular file, look for the index.md file and run that, and that's exactly what we see here. Now, GitHub does warn us that it can take up to 20 minutes for the code to finish building. That has not been my experience. Usually it's 1 or 2 minutes, but it is not immediate. So you may have to wait around a little bit and refresh things before you see your work. But once you do, you can start coming back and modifying it. The way you do it is you just put in some code, or type out some code into the page. So for example, let's say I go back to my, where'd you go, GitHub? Go back to my GitHub site and go back to code. Go into the docs folder. I click on the index file and I click on the little pencil here to make the edit. You can see I've already done this before. Basically I just pasted that code in and saved it. Now the language that's being used here is not Python. It's what they call a markdown language, and GitHub's calling it a markdown language called Jekyll. It's actually pretty easy to learn. This week, this module, you've got enough on your plate that you don't need to learn a whole nother set of markdown. But I'm going to have you mess around with it next module because, well, it's extremely popular out there to set these pages up. And it's really actually pretty easy to do. We'll talk a little bit more about this later on. But you can see this little cheat sheet. I'm just setting up some hyperlinks to point to various different places. And you can use this cheat sheet to kind of find out more about things like how would you put an image in the web page. But again, this week, you've got enough going on. Don't try to make yourself too crazy by messing around with this page more than just getting this simple text printed. That'll be good enough for right now. And then next week, you'll have more time. The subject matter is, as always, still kind of intense for beginners. But I think it'll be a more appropriate place to mess with it there. So hopefully you find that straightforward. I think it is once you know which buttons to click. And again, it's going to be part of the assignment to make a very simple little page like this. Well, that's it for this module. So the questions I want you to ask or be able to answer is, what is a function? What is a parameter? What are arguments? What's the difference between parameters and arguments? What are return values? And what's the difference between a global and local variable? How do you use functions to organize code? What's the difference between a function and a class? And how do functions help your program you to program using the concept of separation of concerns, that pattern of programming? Also, how are the debugging tools used in PyCharm? Oh, I've got a D there. And what's a GitHub webpage? So these are questions that you might expect to be asked on the job, in an interview, and I'd like you to be able to answer those questions if asked. So think through them, kind of write them down, make your own notes. Remember, you can always go back and forth in these videos. You can pause them, you can slow them down, you can speed them up. Just take some time to really get this down, and then when you're done, move on to the assignment and get started there. Okay, thanks for watching, and enjoy Module 6. Talk to you later.